Lucene conceptual scoring formula in Lucene. Now we are considering Lucene conceptual scoring formula. The Lucene refines VSM score for both search quality and usability. Normalizing VD to the unit vector is known to be problematic. That removes all document length information. For some document, removing this info is probably okay. For example, document made by duplicating a certain paragraph 10 times, especially if that paragraph is made of distinct terms. But for the document which contains no duplicated paragraph, this might be wrong. To avoid this problem, different document length normalization factor is used. This which normalizes to a vector equal to or larger than the unit vector. Doc length norm D. At indexing, users can specify certain document are more important than others by assigning a document boost. For this, the score of each document is also multiplied by its boost value, doc boost D. Lucene is field based, hence each query terms apply to a single field. Document length normalization is by the length of the certain field. In addition to the document boost, there are also document field boost. The same field can be added to a document during the indexing several times, and so the boost of that field is a multiplication of boosts of the separate parts of addition, so part of the field within the document. At search time, users can specify boost to each query, subquery, and each query term. Hence, the contribution of a query term to the score of a document is multiplied by the boost of that query term, query boost Q. The document may match the multi-term query without containing all terms of that query, so this is the correct for some of the queries. Under simplifying assumption of a single field in the index, we get Lucene conceptual scoring formula here. The conceptual formula is a simplification in the sense that one terms and the documents are fielded, and the two boosts are usually per query term rather than per query. Now we describe how Lucene implement this conceptual scoring formula and derive the Lucene's practical scoring function. For efficient score, for efficient score computation, some scoring components are computed and aggregated in advance. Query boost. For the query, actually, for each query term is known when search starts. Query Euclidean norm can be computed when the search starts, and it is independent of the query being scored. From search optimization perspective, it is valid question why bother to normalize the query at all, because all scored documents will be multiplied by the same query Euclidean norm, and hence the documents ranks, their order by score will not be affected by this normalization. There are two good reasons to keep this normalization. Recall the cosine similarity can be used to find how similar two documents are. One can use Lucene for example, clustering, and use a document as a query to compute its similarity to other documents. In this use case, it is important that the score document D2, D3 for query D1 is comparable to the score of document D3 for query D2. In other words, the score of document two distinct queries should be comparable. There are other applications that may require this, and this is exactly what normalizing the query vector VQ provides. Comparability to a certain context, extent of two or more queries. Document length norm, doc length norm D, and the document boost, doc boost D are known at indexing time, they are computed in advance, and their multiplication is saved as a single value of in the index. Norm d, index norm d, in the equations in the index norm d. Here you can see a Lucene conceptual scoring formula. Now this is the end of my presentation. Thank you very much for watching it.